Cool. Hello, everyone. Welcome to SIG Autoscaling Weekly Meeting for Monday, 2nd of December 2024. We have a couple of items currently on the agenda. Jin, do you want to start?
Yeah, I'd like to explain the dynamic device steering. Can I start my presentation?
Yeah, sure.
Okay, so I share my screen. Please wait a moment. Can you see my screen?
Yep.
Okay, this is a summary page. Previously, I explained I would like to realize dynamic device steering by using cluster autoscaler and DLL feature. And currently, I'm still writing the TP for dynamic device steering, and I continue to discuss with DLL maintenance, Patrick. And then there are changes from the architecture I previously presented in this SIG Autoscaling meeting. So I want to share them here, and I'd appreciate feedback and comments on this before I submit the TP. And regarding previous my idea, I have a plan to use cluster autoscaler as a trigger for increasing or decreasing devices. And I got some comments. It is difficult to use the cluster autoscaler as a trigger. And I also proposed develop processor for vertical scaling in cluster autoscaler. And this is previous my idea. And so here is a current idea. And the current idea is cluster autoscaler will not be the trigger for vertical scaling. And the pod creation or deletion will trigger GPU attachment or detachment. To achieve this, I have a plan to use the array to dynamically attach GPUs when a pod is deployed to node. And I have a plan to develop a DRA driver for composable architecture for this purpose. But details are still being discussed with DRA maintenance. This is a summary. And the next, I would like to explain the concept of resource slice for composable architecture. There are two types of resource slices. The first is node local resources.
Sorry, just before we move on, Daniel, are you wanting to ask a question on the original?
Yeah, just so they understand the requirements here. So if we're like the attachment of a new GPU or activation of a new GPU happens after the pod already ends up on a node, does that so if that's the case, is it always going to be like is the new GPU attachment or activation always be successful, or are there any situations in which you may not have you may expect to have GPU but not really but then fail to attach it? And if so, how frequently does it happen? Because it will cause the pod to fail in every such scenario, right?
Sorry, I explained. I'm misleading explanation. Sorry. Actual processing flow is here. User create pod by using resource claim, and then when scheduler defer the resource slices, and when scheduler determines which node we can put. Sorry, when scheduler decides the node for pod scheduling, and then kubelet in conventional process, kubelet trigger NVIDIA kubelet plugin for the attached GPU, but in composable architecture, kubelet requests the GPU attachment to composable DR kubelet plugin, and then this kubelet plugin attaches the GPU from the fabric by using composable operator, and then NVIDIA kubelet plugin configure the necessary settings to the attached GPU, and then pod may become running status. So, yeah, so this is my idea's processing flow.
So I'm wondering, what is the role for cluster autoscaler in all of that, in the new architecture? Like, where does cluster autoscaler tie in at all?
Yeah, cluster autoscaler is required for no horizontal node scaling. So if user requests a lot of CPU and memory other than in addition to the GPU, and if the node does not have enough CPU and memory, command scheduler makes the pod unschedulable, and then command scheduler needs to consider which node should be added. In this case, if we consider only node group for horizontal node scaling node group, command scheduler just refer the resource slice for node local resource, but in composable architecture, cluster autoscaler need to also refer resource slice spec for fabric resources. So I think cluster autoscaler, I needed to add the feature to cluster autoscaler to refer resource slices for fabric resources.
So it's mostly about, like, if we would like to scale such a node group with the vertical scaling, we'd need some special processing for that template, right? Because just looking at any of the nodes from this node group wouldn't tell us how a new node would look like. We would sort of probably want to have a template with the biggest possible configuration or something like that.
Yes. So currently, I explained, I expressed the following two features to be necessary for cluster autoscaler. The first one is I would like to add annotations. For example, node has dynamic headroom to distinguish nodes for vertical scaling. And the second one is I would like to add a processor to create node info from the resource slices for fabric for the above nodes. So yeah, this is currently my expectation. But I'm still considering what features is required for cluster autoscaler.
Can I go back to my original question?
Which page should I show?
Can you show the slide with like with the flow of what happens in what order?
Okay.
I think this one. So here, so we have some resource slices in the. So okay, maybe just to take a step back. So I'm assuming this whole feature makes sense because if you're not using some GPU on one node, you can reconfigure the hardware so that this GPU is used on some other node, possibly in another cluster, or somewhere else, right? Like it is useful when you can reuse the capacity somewhere else. Is that a fair assumption, or am I off?
Sorry, I can't understand your
So-
question. So could you speak slowly?
Okay, so I'm assuming that the whole purpose of this is so you can turn off some GPUs and not use them on one node, but possibly reconfigure the hardware so that
Yeah.
this same GPU can be used by some other virtual machine somewhere. Is that
Yes,
true?
yes, right. Resources on Fabric can be attached any node, so we can use these GPUs.
Okay, so if this assumption is correct, then it is possible for kubelet in step 4 here to want to grab a GPU, but no GPU actually being ready. Is that something that can happen, or is GPU always going to be ready for grabbing? Like, is it possible for like some GPU to be connected to some other VM and so on? There's no physical hardware that we could enable, even though in principle it should be possible on a VM.
Yeah, I'll interrupt. That's my interpretation as well, based on this design, is that the design would have to accommodate a pod getting scheduled onto a node that doesn't yet have a GPU, but eventually will when one becomes available. So as long as that's the understanding, then I think that scenario is true.
Mm-hmm. So yeah, my question is, do we want, like, what happens to those pods if there is no GPU available? Do they fail? Do they wait? Or what exactly is going on in those cases?
I don't know. I can understand your question exactly, but if pod fails for some reasons, I need to consider the GPU should be removed, or I need to consider the error handling. But currently, I don't consider the detailed error handling now.
Okay, so maybe fine to follow up on the actual cap.
So how do you determine if a pod can fit on a node? In the scheduler plugin, how do you determine if a given pod can fit on that node? Is it just you always let the pod in based on the maximum possible configuration that this node could get, or what's the algorithm? I think there's just a lot of details to be considered here. Maybe it would be more productive to review this in writing. I'm not sure.
Yeah, do we have access to this slide deck just to look over at our own leisure? Jin, that's one for you. Can we have a look at this full slide deck ourselves? Or are we
Slide
waiting?
deck?
The PowerPoint presentation. So the slides that you're currently showing us, can we have a look at those externally to this?
I'm really sorry. I can't understand your comment.
Sorry, I think it would be useful for us to be able to look at these slides ourselves before the KEP was raised. Just get a bit more familiar with what you're proposing here and where our questions might be. So are these slides already public, or is there some?
Okay, I understand. Okay, I share this slide on Google document later, and I tell the URL.
Okay, that'd be great.
Okay, thank you.
Jack, have you got any other?
Oh, just real quick, the reason I originally raised my hand was to answer the question about how is this going to work with cluster autoscaler? And so I was just going to remark to Jin that the most important thing is to ensure that everything that you're doing here integrates with resource slices and resource claims, and cluster autoscaler should do the work for you. So it should get that pod to the right node that it wants to get to. Now, all the other details that we're asking about, those represent scheduling edge cases. So we don't quite know if the pod gets scheduled to the node before there's actually a GPU device there because some other actor is provisioning the GPU. We have to work those details out.
Yeah, just one point to Jack's points here. So CA integration with the array should take care of everything related to like resource slices, resource claims, as long as the resources between nodes in a single node group are homogeneous. So as long as all of the resource slices for all of the nodes in one node group look the same, this will work out of the box. If the intention is for different nodes from the same node group to have a different state of the resource slices so that we can just go and copy any random one, then we would need to do some custom processing at the template node info stage. So there will be some custom logic needed one way or the other, I think, unless all of the resource sizes will be the same, but I imagine that won't be true here.
I just wanted to bring up the notion here too, that this, like, at some level, I'm having a little bit of trouble understanding like how the paradigm fits in with the way the autoscaler works. Because right now, the autoscaler works totally on the idea of like seeing a pending pod and increasing a scale count somewhere, right? And now we're getting away from the concept of scaling a node count, and we're getting into the concept of like almost scaling a resource, right? And so in my mind, this changes the interaction, or it changes the relationship that the autoscaler has to the activity that it's doing. And I'm wondering, does this still fit into that methodology?
I think, and this is unrelated to this proposal here, this is just like the array in general. I think the same was true previously. We were always actuating a resource, and that resource being the node object. And predicting that node object correctly wasn't just as simple as just bumping an int and that's it, we're waiting for that node. We needed to predict it always. So now I don't think there is a big like paradigm shift here. It's just that instead of predicting just the node resource whenever we're copying a node, we now need to predict the node resource plus a bunch of other resources attached to it, sort of. So a node and then some resource slices. And this is I think that ship has sailed, and this is just needed for the array. And this is unrelated to what's being proposed here.
So let me.
Yeah, to be clear, when you say we there, Kuba, you don't mean cluster autoscaler would do those things.
Sorry, which things?
Proactively populate a resource slice or a resource
Yeah,
claim or all that
that's
kind of.
exactly what we need to do. Like whenever we inject a new node, we need to take some other node or some like template that's not existing, and then based on that, fake some resources and inject them into the cluster snapshot. We're not, of course, changing the actual cluster.
I see what you're saying. Yeah.
In memory in CA, but we do need to be able to do that.
So let me just make sure I understand you there, Kuba, because I think what you're saying makes sense. So you're saying the node representation has the resource slices for the GPUs that could be there. And so we can schedule normally, but the autoscaler needs to become aware of when those resources could be made available so that the pods can be scheduled properly and it doesn't create extra nodes.
So just for DRA, and taking away this
Right.
proposal, just for DRA, it's not that the GPUs could be available there. It's just that you can just think about it as extending the node object. It's just we're not doing that. We're adding a reference and adding all of the new fields into a new object. So it's not that if the resource slice says that the node exposes a GPU, we are just like, well, the node does have the GPU available. The scheduler can let pods in that request that GPU, and then once the pod is in, the scheduler communicates with the appropriate DRA driver to actually sort of get this device up and running, but it was always there. And so for just DRA support in Autoscaler, we just say, well, there's this node, it has these resource slices, let's say it exposes 2 GPUs. So now if we add a new node from this node group, this means that there's a new node object in the cluster and 2 new resource slice objects in the cluster representing the new node GPUs. And that's just the array. And now this proposal is, I think, trying to stray from that and either trying to say that the resources exposed via resource slices are not actually there, or to have different resource slices between different nodes in the same node, both of which would require some custom logic to make it work in CA.
Yeah, I appreciate that. Yeah, it makes sense to me. Thank you.
Okay, I will check the recording after this meeting.
Yeah, Jen, I would say start writing it up as the KEP so we could discuss it there.
Yeah.
It's a complicated idea and we need to see the details so that we can respond to them.
Okay.
Yeah, you don't have to make the proposal too detailed. It can be like a preliminary, just a very high level idea that we can review and that keep fleshing it out, so that you don't waste too much time if we need to go in the other direction.
Okay. At first, I will share this slide.
Awesome. If there's nothing else, Rahul/Ben, I know we've only got 2 minutes left. Is that enough time for you, or do you want to push out to next week?
We can push back to next week.
Okay. Sorry about that. And yeah, same to Erno.
I will, Guy, I will add a comment on that. I talked with Rahul and Caitlin at KubeCon about some of this gRPC stuff. So, Rahul, Caitlin, Ben, I'll try to take a review on those this week. And maybe we can make a little progress before next week then.
Yeah, sounds good. Thanks.
Awesome. Thanks very much. Cool. In that case, thanks very much everyone for attending, and see you all next week.
Thank you.
Bye.